Hey folks, Dr. Baker here. In this brief video, we're going to talk a little bit about how to estimate demand curves using empirical data. In particular, we'll talk about how to do this in Excel, focusing on a very powerful function in Excel called the Linest tool. First of all, let's rewind our brains back to our intro microeconomics course. Remember what a demand curve even is, right? These were lines or curves that you saw many times while you were working your way through economics problems, right, in your text. And the idea was that at some quantity demanded level in the market, looking on the right side here, there was a given price that sellers could set the product, right? Or conversely here on the left-hand side, by setting the price of a product at a certain level, there'd be a certain quantity demanded. And of course, there's a negative relationship between these two things. As you increase price, the quantity demanded for a product will go down. Now, profitability may not, of course, right? We can sell higher price products and fewer of them and make a hefty profit, like luxury goods in many cases. But the one thing that is often overlooked in these intro microeconomics courses is, where do these curves, or often lines, we call them curves, where do they come from? Like, why is the curve the particular shape that it is when we're talking about the price and demand for corn, or price and demand for vape pens, or price and demand for digital avatars for a video game? We often take that for given. Well, today, let's talk about some approximate techniques to actually estimate demand curves. And I say approximate because actually precisely deriving a demand curve is very theoretically challenging, in some cases intractable, but we can approximate it with some basic techniques. One last thing I just wanted to point out really quick here is you might notice in this example that I have here, price is on the x-axis in one version and on the y-axis on the other. And why is that? Well, for economists, they tend to think of the world in terms of marketers being, or businesses being, price takers, meaning there is latent demand out there in the market, and then the price that they can afford to sell at is a consequence. So like literally demand drives price. From the marketer's perspective, right, for a single organization, we at least like to imagine that we are in control of price, right? We can control the pricing lever, and that will have an impact in a relationship with quantity demanded. So that sort of which one's the input and which one's the output is a bit theoretical. Admittedly, economists typically have it a little bit more right. We often are price takers, but we do have this role of setting prices. So we tend to think of it more as price on the x-axis, or the input. So to illustrate this example, let's hop over to our Excel worksheet here. And I zoomed in very closely into a simple data table here. And it has 10 observations, price, and estimated quantity sold, or actual quantity sold. And what this represents is, let's imagine that we work for a minor league baseball park, and for a given series, when teams come and visit and can play against us over like three games or so, 3 to 6 games, we varied our price for a standard hot dog differently. So, one of these series we charged $2, another one we charged $4.99, kind of in an experimental fashion. And we observed these 10 different windows of setting prices. And then we tracked and saw, well, how many hot dogs did we successfully sell over that series? And we simply then plotted the price versus sales relationship on a simple X and Y axis, right? So if you look at the little dots here, we can see that it looks like there's clearly a negative relationship, right? As we increase price, quantity demand goes down. But the exact shape of that relationship is a little unclear, right? Maybe it's curvilinear, standard linear, or something else. And also, we should keep in mind, again, I said we're going to approximate demand curves, right? There's a bunch of other factors other than just the price of the hot dog that probably affected demand, right? Maybe a very popular team was visiting for a series. And that would, of course, mean there's more people in the park, which means we sell more regardless of the price of the hot dog. Maybe the weather was good, maybe the weather was bad, and this all has impacts on hot dog sales. So we're sort of ignoring all these other factors, which are important, and we're just going to approximate the price and demand relationship. Now, an easy way to do this, which you're probably already familiar with in Excel, is we could simply click on the little dots here of our scatter plot. Here, make it so I can edit it, of our scatter plot here, and we could add a trend line, right? And we could start with a simple linear line and show the equation. There it is. Or we could do a polynomial to the second order, and so on. Now, this is it. Like, you have successfully generated a demand curve, whether it's good or bad, but you have done it. Like, we literally can now say this is the modeled relationship between price, the X, and on quantity demanded, Y. Congratulations. But there is a limitation here. When we set trend lines using the trend line tool in our scatter plots in Excel, we can't really do much with this equation, right? These numbers are sort of trapped here in this text. We could manually type them down into our spreadsheet and do some additional spreadsheet work, but that could lead to error. What if we change the model? Those numbers wouldn't update automatically. That could cause a lot of problems. Ideally, what we really would like to have happen is whatever model we pick. In this case, I'll switch this to a polynomial to the second order. Oh, yeah. Let's say we like this one. I would like to get these three numbers down into my actual spreadsheet cells so that I can do additional spreadsheet modeling work. So here's how we can do that. This introduces us to the mighty Linest, linear estimator function in Excel. And the linear estimator tool can do all kinds of things. It's very, very powerful. But most notably here, it allows us to estimate a specified linear relationship between a single input and an output. And for now, one of the things that's immediately apparent about this particular function is we want it to do something a little different than we're used to in Excel functions. Notably, we already know in this particular case that we have three different numbers or values that we want to have come out of the function, right? But typically, we're used to having Excel functions where all the results come into just a single cell. But this case, we need the results to come over into three separate cells. Whenever you have a function in Excel where the results might spill over into more than just one cell, that's a special type of function called array functions. There's all kinds of array functions like matrix multiplication, etc. But the linear estimator is just one of those. And to set this up, I already kind of pre-format it so it's a little easier for us to work with as we're new to it. We simply just go linest, right? So we got our function going. And then it says, what are your known Ys? So these are the outcomes. In our case, it was estimated quantity sold here, right? Then comma. And then it says, what are the known X's? And here's our price, right? That's the input. There we go. And now there's something additional we have to do. So input, output. But there's one more thing we have to do here called, I did add a caret, a squiggle bracket. It's important, it has to be squiggle bracket 1, 2, and close the squiggle bracket. Now, why are we doing this? This is not something you would know at all intuitively, right? This is, I happen to know, having worked with the linest function a lot, that if I wanted a power series model, like we have up here in the quadrant here, where we have not just the linear, we also have the input squared parameter here as well. If I want to do it that way, I can do that, but I had to add this little caret squiggle bracket 1, 2 thing to the power of 1 to the power of 2. Again, only way I knew that was by virtue of watching a video or reading stuff online or reading the help menu. So this is your introduction to some of the stuff that the linear estimator can do. Okay, now that we've had this all set up, we have one more comma here. We do want the true here. That's going to just make sure that our intercept is calculated normally. So as we see here. And for now, we'll also then put there's one more parameter. We'll set it to false. This just is going to turn off additional stuff that the linear estimator can give us, which we don't need right now. So you can say return, and voila. So first thing you should notice is, oh wow, when my results as desired weren't just in one cell, they spilled over automatically into 3 cells. Very nice. And also, if you click here where I first typed it in, I can see up here the linear estimator functions like dark black as normal. But if I click over here or here, it's lightly grayed out. So it's sort of saying like, yeah, the function's back in the original cell and I just spilled the results over elsewhere. Like for example here, I'm trying to just delete just this single cell and it's not doing it, right? Because the array function's all attached together. It's one thing, even though there's 3 separate cells you can reference. So if I wanted to delete this, I'd have to select them all. But I don't want to delete them. I'm very happy to be working with these. So first of all, let me illustrate why it's so important to use something like the linear estimator rather than just hand typing it in from the trendline tool. Let's say management comes back to me and says, hey, actually for observation 1 here, we had an error. The price was actually set at $2.49. So you just update that. And then sure, the numbers did update over here, but if we had typed this by hand, these numbers, if we had typed these by hand, those numbers wouldn't have updated, but they did update because we have our functions all attached. It's great. Okay, now let's do one last little bit of work here. Let's see if we can actually help management set the price for their hot dogs based on our model. So we assume that the marginal cost per hot dogs is 99 cents a piece. We're trying to figure out what price we should set our hot dogs at. In this case, right now, we just have this is our input, 99 cents. It's not attached to anything, just a raw value. So what is our demand? Well, our demand is this equation based on this price. So I can just type this in now. Okay, equals my constant. And we've done this type of exercise many times, right? Types our beta 1 parameter times our input plus our beta 2 input times price, and then squared, right? This is just a simple power series model to the power of 2, just like we calibrated. Great. So now we have it set that if we set our price at 99 cents, our demand will be 30,000 units. Well, what's our profit going to be? Well, there's lots of different ways to type this. I'll do it the long way because I think it's just easier to see. Well, our revenue, let's see, our revenue first would be our price times our demand. That's our revenue, but of course, we have to also subtract out our costs, right? And we got to pay 99 cents right now for each one of those hot dogs. So $0. But what if I set my hot dog price to say $1.50? There we go. I make a profit of $11,506 because I'll sell fewer units, but of course now I'm actually making margin. And now this brings us to sort of the normal culminating step of a lot of spreadsheet models. Now that we have a input price connected to a meaningful output profit, we could optimize. So I just go to data. I go to my solver. And I say, okay, let's see if you can maximize my profit by changing my price input here. And let's just see if I can solve and don't have to adjust any other constraints. Great. Okay. So it says, hey, actually, you should be setting, if you want to maximize your profit, your hot dog prices should be about $2.30. I probably would tweak that to $2.25 or $2.50. That's kind of an odd price point, but we're getting very close to like figuring out the right way to set our price. Ta-da! Easy peasy, right? Okay. The Linest tool is very powerful, and you're not going to master how to use it all in one fell swoop. But always keep in mind what we use the Linest function for is we want to build an input output model on a continuous output, standard sort of regression stuff. And there's a few basic settings that we can do to set basic standard models. So for example here, look at here where it says polynomial to the second order. This is the demand curve that we just built, right? y-intercept, beta 1, beta 2 with x squared here that we just built in the previous hot dog example. And the way that we do it is we use the Linest function where we select the y, we select our x column, and then we do the little squiggle bracket 1, 2, just as we showed. What if we had wanted to build just a simple linear model? Well, exact same thing. We just didn't have to include the caret squiggle bracket 1 and 2. And now instead of having 3 cells of output, we only would have had 2 because we just have the y-intercept and the slope parameter. And we also could have done a polynomial to the third power. We would have done squiggle bracket 1, 2, 3, etc. if we wanted 4 or 5. We can also do multiple linear regression. What if we have multiple inputs, not just price, something else? Well, we can do that just as well. And we can even get more creative with more exotic functions that we don't really typically do in our introductory analytics class, but power functions, exponential functions, and even logarithmic functions. So these can all be done as long as we follow the specified rules of how to set up our equation as illustrated in these slides here, and also available through documentation online. Okay. Let's conclude with one final example of applying the Linest function. Now we have something a little different. This time we do in fact still have like hot dog sales for a minor league ballpark. We do have the price that we were selling the hot dogs at. We also have the estimated quantity sold, but there's one additional thing that we know now that we didn't know previously. We know whether or not a particular series for the games happened on the weekend. 1 means, yes, this happened during the weekend, and 0s, they did not. And I can't be exactly sure, but if I'm just glancing at this, and my intuition would say, hey, weekend series are probably better attended, regardless of the price of the hot dog, we're probably selling more hot dogs on those days. So in this case, what I would like to do is I'd like to build a model that shows the relationship between price and quantity sold of hot dogs, but for either weekday games, 0, or weekend games, 1. And we can still do that with Linest. So now I go down here to cell A25 and I do my Linest function. And in this example, I'll select my known y's. Here's my observations. And this time it says select my known x's. I'm going to select both columns. And so now I have 2 inputs, right? So I'm going to have a parameter for weekend, a parameter for price, and the constant. So still 3 outputs, but now I incorporate the weekends. Also in this example, I have chosen to not make a curvilinear relationship. I am choosing that price has just a linear relationship with quantity sold, just different than the previous one, just to illustrate it in play. So true, I do want the constant calculated as normal. And this time, this last setting for our function, I will also set to true, just to illustrate something else that Linest does. And when I run this, we're going to get a whole bunch of output. So how to think about this is actually just the standard output that you have seen in any sort of linear regression package, whether you did linear regression in Excel, SAS, Stata, SPSS, Minitab, any other software, just standard regression stuff. The first row is the most important for us. They are the parameters, just as they always were. The next row is the standard error. This is the amount of uncertainty sort of in our estimates of these parameters. Even though we see NA here, that's correct. It's just that these bottom 3 rows here only have 2 columns worth of additional information. So there's just nothing else in these other cells. And maybe for us, at least, if we're just glancing quickly, the one that's the most intriguing is this R squared one here, right? So this R squared says our model just using price and just using whether or not it's the weekend, we have an R squared of 0.75, pretty good fit between the data and the outcome. Cool. So I just wanted to illustrate that you can still get all this additional stuff when you use Linest. But we're just going to focus on these beta parameters for now. All right, so let's do the management simulation tool. Okay, now we have 2 inputs, right? We have either the price of the hot dog or a 0 or a 1 representing weekend or not weekend. Our demand just follows the form of the equation that we specified. So our constant here plus price times this plus now weekend. And sure enough, oh, the weekend's a positive parameter. Yep, indeed, when it's a weekend, we sell more hot dogs regardless of the price. So now we have our demand here, and now we can estimate our profit. And that would simply be our profit is our, I'll do it a different way this time, just so we can see it both ways. Price minus the marginal cost times, of course, why demand it. Do a little mathematical rearranging. We don't make any money. Oh dear. What if we charge $1.25? Yes, we make some profit. Okay, so now let's run solver. Now, what do we do with this weekend input? Nothing. What do I mean by that? Well, our objective is still to maximize our profits. And which variable cells can we change? We can't change, we shouldn't change weekend between 0 or 1. Weekends and weekdays just happen to us. They're not things that we can toggle. Like we can't take a Tuesday game and make it a weekend game. So price is still actually the only input we can manipulate. So I'm going to run it first here. And what I see here, how to interpret this is at a price of $3.74 during weekend games, my profit is optimized, about $27,000. Now I'd have to run this a second time. I'll turn off weekend, turn it to a 0, and I would run it again. It's entirely possible that a different optimal price exists for weekday games. So I'd solve it again. Bingo. Yes, during weekday games, I should only be charging $3.20 for my hot dogs. And my estimated profit is lower than a weekend, but that's still the most profit, at least according to my model, that I can make. Cool. Okay, everybody, this was a very brief introduction into how to estimate simple demand curves using Excel and the mighty Linest function. Good luck excelling out there.